This is section 8.5, day 1, and today we're going to talk about trapezoids. So trapezoids, if I ask kids to draw them, they usually draw something like this. There are two bases and then what are called the legs of the shape. So you've got two bases and two legs. A trapezoid is not a parallelogram, so it has none of the properties that we have already been working with. It has its own set of properties. What makes a trapezoid is this line right here, and it goes through both boxes because it's true for both trapezoids and isosceles trapezoids. So trapezoid has exactly one pair of parallel sides. The difference between a trapezoid and an isosceles trapezoid, if you remember, the word isosceles just means that it has two sides equal. We had that in triangles. So here our two sides would be the legs. So they have congruent legs. Essentially has two sides equal. The lower and upper base angles. So what I mean by that is one lower and one upper base angle, they are supplementary. And that is going between both boxes because that's true for trapezoids or isosceles trapezoids. So it doesn't matter what shape you have. One lower and one upper base angle are supplementary. In just an isosceles trapezoid, so an isosceles trapezoid would look like this. These are the same, these are parallel. The base angles, so like that one and that one, they are congruent. It also works for the top, so these two would be, or I'm sorry, that one would be congruent to that one. Opposite angles are supplementary. Where this is going to get confusing is because it was opposite supplementary. It was opposite when we did parallelograms. The consecutive angles or the base angles were supplementary and the opposite angles were equal. So this is a huge part of what students get wrong on a test because it's mixed up with parallelograms. In an isosceles trapezoid, the diagonals are congruent. So we're going to show that QRST is a trapezoid. In order for it to be a trapezoid, we have to have two sides that are parallel and two that are not. So I need to do the slope formula on every single side and show that just two of them are the same. The slope formula is y minus y, so 4 minus 2 over 2 minus 4. So 2 over negative 2, that'd be negative 1. T to O again, y minus y. And x minus x, so 2 over 4 is a half. Make sure that you're always reducing your slopes. O to r would be 3 minus 0 over 0 minus 0. So this is 3 over 0, which is undefined. And then rs is the last one. It would be 4 minus 3 and then 2 minus 0. So we've got a 1 over 2. So we've got one pair that match and one that doesn't. That sounds better. So, oops, QRST is a trapezoid because we have one pair of parallel sides. All right. In trapezoids, we talk about something called a mid-segment. It's located right in the middle of the trapezoid, and a mid-segment of a trapezoid connects two midpoints. So MN is a mid-segment. It connected the midpoint from this side to this side, and when you draw between them, that is a mid-segment. Mid-segments do two things. They are parallel to the third side, or I'm sorry, parallel to both bases. And they have a little formula to find them. So the mid-segment is equal to half the base plus the base. So AB plus CD. So top plus bottom cut in half equals your middle. We're just going to try each of those ideas down here and then we'll be done. So this is an isosceles trapezoid. I have the two tick marks. So that means that my base angles are the same. So this is a 50. These two have to be supplementary. So 180 minus 150 is 130. And then this is also 130. Sneak that in there. Then we've got a mid-segment. So MN is the mid-segment. Find the length of MN. So I'm going to take my top plus the bottom. That says 28. Divided by 2 equals the middle. So 12 plus 28 is 40. Divided by 2 means that MN is 20. So that's trapezoids. Make sure that you keep those properties separate from parallelograms. Don't let that mix you up.